So just by way of introduction and a little bit of background, my name's Derek Yu. I've been working on building, software as a service and cloud technology companies my whole career. So that's, over 20 years now. And, most recently, I'm the CEO of PureStake. We've been running a validator on the Kusama network since, the start of that network last year. And I wanted to talk to you today about our new Parachain project called Moonbeam. One more kind of small tidbit is that, I have kind of a personal interest in the history of technology. I actually studied some of this even when I was at the university. And, I added a few kind of historical examples from the history of technology into the presentation that have helped me think about, blockchain, about our plans for Moonbeam. And hopefully, you'll find those interesting as well. So I was going to start here with this quote, which maybe some of you have seen before. So this is from 1943. Thomas Watson, the then CEO of IBM, said, "I think there's a world market for maybe 5 computers." And when you see this quote, sometimes it's pulled out with a kind of a commentary of, oh, what an idiot like this guy was. And here's the thing: this guy was kind of no dummy. He had a pretty keen sense of the market and how to sell technology. And what's interesting to me is when you kind of dig in and look at what was actually said at the time, what were some of the reasons given. The kind of rationale was, well, there's only this very small handful of people that actually even have the skills to build and use these things. They're extremely unreliable. The energy that is required to make them run is quite large. Just even the heat that's given off from all the vacuum tubes is extremely large. And, there's just huge costs involved in these things. And, that means that there's going to be this kind of small market for them. And, the thing that strikes me is, when you think about it, I mean, we all have, that friend that's a Bitcoin or Ethereum maximalist. A lot of this line of reasoning, if you replace computer with blockchain, I think it starts to sound pretty similar, right? It starts to sound like what, that friend of yours that's a maximalist, for Bitcoin, let's say, would claim. And so whenever I hear that line of reasoning, I kind of think about Thomas Watson here, and, I'm careful not to make the same mistake. And I think his mistake is this, that, when you have a novel, technology that does something useful, like a general purpose computer or like a blockchain, don't underestimate, the basically the effect of engineering and human ingenuity over time to make that thing cheaper, faster, better, and adapt it to a variety of use cases over time. And so I think with blockchains, I already see that happening, right? So there's all these new platforms launching, Polkadot among them, and in fact, I see Substrate as a step in that very same story of making kind of a engineering and human ingenuity being put to work to make this thing that was formerly very difficult easier, faster, better, and enabling kind of the adaptation of this technology into a variety of use cases. And you can see this whole ecosystem of projects that have spawned up around building on top of Substrate at this point. So for me, for us, when we thought about this, it was quite clear to us that the future is a multi-chain one, and it's only going to be increasingly kind of multi-chain over time. So I think if you kind of take that as a premise, there's some interesting challenges that fall out of that, because by default, all of these chains are kind of these islands, right? I mean, they're kind of islands onto themselves. And so if you're a user on one of these chains, you kind of only have access to the things that are close to you, right? Only the services that are on that chain. If you're a developer looking to build something, it becomes kind of challenging in the sense that there's this splintered market, right, of all of these small islands. And the question is, where to build. Each of them might have a different technology stack. And it becomes difficult to kind of reason about, well, how do I build to get access to these users and these assets that are on these different islands? And there is this kind of also this trend happening for chains where I think the challenge there is the one way that these islands have to interoperate today that is being heavily used are basically centralized exchanges. So, assets are flowing in from these chains or tokens to centralized exchanges. But especially for these newer proof of stake-based chains, rather, where the tokens carry governance rights, that creates kind of a challenge where, these centralized exchanges now become, kind of major, players in the governance of the chains, right? Major kind of power players. So there's kind of this unique, set of challenges. And, when we started looking at this, we realized that, interoperability between chains would enable, kind of interop scenarios to connect these different islands, that was kind of a critical component of this future world. And so when we started looking at that, I mean, you start thinking about, okay, well, what's a platform that we could use to, to help, help enable interoperability? I think that you kind of quickly realize that there's only a couple options. I mean, I think Polkadot and Cosmos are two of the obvious options. And so when we looked at this, we felt that Polkadot really was the right solution for us, and we have a preference for Substrate and Rust over Go. We also feel that the kind of more structured design of Polkadot is going to lend itself more easily to different kinds of interoperability scenarios versus, kind of maybe the looser, more federated approach that's on Cosmos. So this, cross-chain integration is something that, is a key motivation for us in our project. So just to talk about Moonbeam a bit. So, Moonbeam, we are going to be a smart contract parachain on Polkadot. We're actually going to be deploying to Kusama as well. And, the first question, that comes up is, okay, well, why smart contracts, right? I mean, after all, you have Substrate. So, as a project that wants to build on Polkadot, why not just use Substrate and build a parachain or a parathread? And I think for us, the answer to that question is that, Substrate is quite powerful, very powerful for building blockchains, but it also is fairly complex. And when you're building, a full blockchain, you kind of take on responsibility for certain components or aspects that, aren't necessarily the case when you're building an application that has a smart contract backend. So things like, incentivizing a set of nodes, right, to run the network, what the token economy is going to look like, like governance questions about, how the chain is going to be governed. As a smart contract, a lot of those things are kind of, you rely on the underlying platform to provide some of those functions. So in that sense, they're simpler and easier. And so we see kind of this role of smart contracts as being kind of a simple and accessible way to work with Polkadot, and see ourselves as serving as kind of an on-ramp to Polkadot. I spoke about the cross-chain integration scenarios. I'll leave a bit of those for later, but the other big thing for us is around providing compatibility with Ethereum-based technologies. And before I kind of dive into that, I'll go into maybe just a second example that helped us kind of think about this. So if we started in 1943, let's go forward 35 years or so to 1978. So in 1978, Intel launched the 8086, and this was kind of a quirky thing, right? So this chip was actually, according to the designer, intended to be short-lived and have no successors. It was a stopgap solution for Intel. They were working on their true next-gen, product was a 32-bit chip called the 432. They needed to get something out quickly to kind of help just kind of stopgap and shore up the market for them. And there's little quirks about this chip too that have come to have lasting significance. So things like the choice of a reverse byte order, creating this kind of little endian versus big endian, kind of discussion, which is, had these kind of far-reaching consequences for just what was an innocent decision at the time. But this chip, came out as a stopgap, and it had many competitors at the time. So there was Zilog, had an offering, Motorola. And even when you look at Intel, then over time, they repeatedly tried to replace it with their next generation offering. So it was the 432 that I mentioned. They had an 860, 960. Early on in my career, I worked on 64-bit Linux systems running on Itanium. And every time the x86 family of chips won. And so the question that I find interesting is, why is that the case? Why did this thing that wasn't even intended to be long-lived, outlast all of these other, basically win the battle against all of these other chips, and come to power, most of the desktops, laptop servers, that are out there now. And the answer I think is twofold. On the one hand, they kept making it better, right? So kept getting incremental improvements out of it. But the second, and maybe the thing that I think about more, is that there was an extreme care made for backwards compatibility, and they're developed kind of this large ecosystem of companies, partners, tools, software, operating systems, around this chip. And over time, that that whole ecosystem became quite significant, and created a lot of staying power for this technology. And so I think about this in the context of our Moonbeam plans, and kind of the desire to create Ethereum compatibility, where I do think that things like the EVM and some of the related technologies around Ethereum have the potential to have the same kind of effect, where there's just a large ecosystem of partners, companies, tools, software around that platform. And we're interested in kind of engaging and collaborating with that ecosystem versus trying to prepare or trying to compete directly with some kind of alternate offering. So just to start to dig in a bit to what we're talking about in terms of Ethereum compatibility. I think when you look at projects out there today, I think there are a number of them, that existing projects that are deployed onto Ethereum, that are trying to figure out their scalability strategy. So they were trying to figure out now, well, do we pursue kind of a layer 2 type solution, for example, like ZK rollups, side chains, or do we consider moving to a different platform? I think one of the main points of friction around moving to a different platform is this prospect of taking all of the existing code that's been written and effectively needing to rewrite it, right, to a different technology stack. That's kind of what they'd be looking at, for example, if there were to be a porting effort from, let's say, Solidity-based smart contracts and a Web3-based front end. Would have to be rewritten using Polkadot.js and Substrate for a full port to Substrate. Obviously possible, and I think it's the right decision for a lot of people, but I do think it is a point of friction. So one of the things that we aim to do is to try to lower that friction, right? So by creating support for Solidity-based smart contracts on Moonbeam, creating a Web3 compatible service provider, so that people can with minimal change move their front end, the front ends of their dApps to Moonbeam. And that's kind of our concept is to make it easy for people to move on to Moonbeam, and then from there could be an upgrade path even to a full parachain or parathread, if full control is needed over the application environment. So just to dig in a little bit on the on the architecture, some of the components we can stand on the shoulders of giants to leverage. So obviously that's all of Substrate and the frame system. In particular, there's the EVM frame palette that provides a full Rust-based implementation of the EVM based on Sputnik VM. Quite excellent. I think that's an important part for us because that kind of ensures that there'll be faithful execution of people's contracts that we're trying to move over. But there are some components that we'll need to create. So in particular, if you move over to the left side, creating this Web3 RPC compatibility layer is going to be an important part of the work. We want to make it so that an existing dApp front end or even a tool like Truffle can connect to a Moonbeam node and think it's connected to yet another Ethereum network. So from this Web3 RPC kind of entry point, there will be a substrate runtime, and these calls will need to be kind of handed back into the substrate runtime, where they'll need to be decoded, and ultimately, they would be dispatched, back for execution in the EVM frame palette. I think the challenge that some of the challenges we're working on right now are that, the EVM frame palette, provides this faithful environment to execute smart contracts. However, it is a bit of a, kind of a self-contained island inside of the substrate runtime. So, a lot of the trick here is basically being able to, integrate, this kind of EVM into the runtime in a way that makes sense. And so that's, a lot of the work that we're working on now. A few things that, I would point out that, we know won't work, or won't work the same. So for example, any apps that rely on, current, kind of ETH internals, so things like, the Ethereum proof of work consensus like algorithm, obviously won't make sense in the context of a substrate-based parachain that's using, a different block production mechanism. So that would be things like, difficulty, uncles. I mean, these things, simply won't make sense in the context of Moonbeam. So there is some class of smart contracts that, won't be easily portable. So things like, I can imagine mining pool contracts, other things that rely on these components. The good news is, I think that those are in the minority when you look at the different kinds of contracts that exist. Just as a matter of practicality, we realize one of the components that we're going to have to provide will be, some tools to help with state migration. So, there needs to be some way for a project on Ethereum to export, state related to, accounts, storage, code from Ethereum, and, take that export and import it into Moonbeam. Once Moonbeam is up and running, there will be some costs associated with that, but that's a good example of the kind of thing that will obviously be, heavily motivated to subsidize, any costs related to, migration of projects, onto our platform. Just thought I'd comment a little bit on the collators, for Moonbeam. An obvious choice to incentivize a set of collators that I've seen some other projects were using would be to use the staking frame palette. Our feeling is that, as a parachain that needs to incentivize collators, the staking frame palette is, a bit overkill. I mean, as a parachain, you're already kind of, locking up dots to get the shared security from the relay chain. And really what you need from the collators is, to guarantee block production. So, in addition to that, we also have a fixed supply on Moonbeam. So the staking frame palette kind of assumes an inflationary model to some extent. So, we will be creating a custom kind of collator incentive palette that will incentivize node operators on Moonbeam. That also, there is another point here where, by not including staking on Moonbeam, that is one less thing that would compete with potential projects, DeFi-oriented projects that want to create yield-producing services for users. So then we're kind of removing an element of built-in kind of competition for those potential projects. So that's another part of our plan. And what I want to do is just, we're obviously kind of focused on some of these Ethereum compatibility pieces in the short term. But going back to that broader vision, from the beginning, I mean, this kind of notion of interoperability is something that really motivates us. And sometimes kind of internally here at CureStack, we've used this analogy that if Polkadot is like Linux, then maybe Substrate is something like the standard C library. And these parachains that will be on Polkadot could be kind of like the do one thing and do it well specialized tools that you find on a Linux system. In that context, we see kind of on the longer term, Moonbeam having a place on Polkadot as kind of a bash-like thing. So what do I mean by that? Well, just a simple, accessible place for, some of these purpose-built tools can be combined in novel kind of configurations or composed to achieve larger effects. And, we might start with that, And then if you need kind of the full performance of a parachain, you might upgrade then to a parachain or parathread as necessary. But it's not clear to us that you would kind of start right out the gate with a parachain or parathread, given all of the other things that all the other overheads that are involved with creating one of those. And just to give a kind of a North Star vision for us of where we'll be quite interested in kind of working in the future as these interoperability functions come onto the Kusama and Polkadot relay chains, XCMP and Spree in particular, are some other projects we've spoken with, right? So there's Kala and their AUSD stablecoin. Interlays designed this trust minimized BTC bridge. Chainlink is building a parachain that will offer Oracle services or prices basically to other participants on Polkadot. And so we can imagine kind of combining those three things into a lending and borrowing protocol, let's say between BTC and the stablecoin AUSD. So that's not possible today, but these are the kinds of interoperability scenarios that that motivate us and that we see as kind of the things that we really want to engage with as those functions become available. So I started the talk with this example from 1943. I thought I'd end with going back 90 years before that to July of 1853. And what happened in July of 1853 was that the so-called Perry expedition arrived in Edo Bay in Japan. Just I'll pause for a moment and just give a little bit of context for those of you that aren't familiar with what happened here. So the context is that Japan under the Tokugawa shogunate had pursued this kind of isolationist strategy for good over 200 years before this time, where there was extremely limited contact between Japan and other countries for trade and for other things. And Admiral Perry, in command of a U.S. naval fleet, was sent to Japan with the goal of opening the Japanese market for American goods and services to reach a trade agreement. And so what ended up happening is that he arrived with a fleet of kind of modern warships that had all the latest kind of naval guns and different technology and well-armed Marines. And the Japanese kind of didn't have the technology to kind of deter them. And in the end, they did achieve the trade agreements they wanted and opened some of these Japanese markets for trade with American goods and services. So I'll be quick here to note that my use of this example is in no way kind of an endorsement of gunboat diplomacy, violence, or the threat of violence. But there is something that sticks with me about this example, and I think and that I think is applicable to blockchains. And I think that what that is for me is this: that we're building these blockchains, and they're all these kind of they're like these small economies, right? They're like these whole economies. They're small right now, but I expect that they'll grow substantially over time. And as these economies grow, they're going to come into contact with one another. And as that contact happens, for one, I think that it's going to be extremely difficult to pursue this kind of isolationist strategy, particularly if you're a public and permissionless chain. And that there's going to be this kind of market force that's going to drive for connectivity, right? This kind of built-in market force that's going to be very hard to resist. And it strikes me that in this future world, it's these kind of shipping lanes and ports of call that are going to be some of the most interesting places to be and to be building. And the best we can tell, a lot of these shipping lanes and ports of call in this future blockchain world are going to be built on Polkadot. That's our belief. So so that's kind of why one of the reasons that we're here. Just to end, we did just announce our project more formally. Just yesterday, we put up a new website, so you can find that at moonbeam.network. We're actively seeking Rust and Substrate developers that are interested in helping us build this project. Node operators that are helping, that could help us run it. And we'd love to hear from other Polkadot projects, Ethereum projects, where that could find Moonbeam useful. Always interested in engaging with folks in the ecosystem. So please feel free to reach out to me directly. I'd love to hear from you.